Welcome back to another Forge video. Today I'm going to show you how I made my nitrous goose. So it has this boost that you can hit with the mark, which is super handy. There's a cooldown time in between each boost. So there's 5 seconds that you have to wait for the cooldown. I can't get this to work where you can only boost on the ground since the get is player in air or get player is in air, or can't remember what it was. That does not tell you whether or not the player who is on a vehicle is in the air. So I can't unfortunately do that check. But what we can do is still make boosted gooses, and I think that just sounds really cool. So let's get into it. Let's start with our variables. This is going to be really simple. So we have the Boolean of can boost. So that's whether or not you can boost, and we control that because if the player hits boost, we don't want them to be able to just hit boost again and then immediately just spam the boost button. Now, so what we're doing is we're setting that to false. We're checking if it's true and then immediately setting it to false, and I'll show you that later. The boost cool off here, that's the number of seconds in between each time that you can boost. You can mostly just ignore this use stepping behavior. This will always have to be true, and I'll show you that later why that has to be true. It's basically because the other side of that, if I set this to false, basically the code will go nowhere because there's a branch where this is used and the false condition is not connected to anything. I had an idea where I wanted kind of like an impulse mode, quote unquote, like to where you immediately apply a scaled velocity, but instead what I chose to do is step through multiple scales or scalings of the velocity, and I'll show you that, of course. The number of steps that we're going to take is here, so number boost steps. Number boost duration, or boost step duration, is the number of seconds in between each of those steps, and so it's pretty small. It's 0.12 seconds here. Then I have the number boost step curve scalar. So this is something that will take a little bit more context to explain, and I will, of course, show you that later. But these values right here, the coefficient divisor and the scalar, I use those in a function to build an acceleration curve. So let's start off with the player mark event. So what we're doing here on player mark is we're going to grab the player, and then we're going to get the player's vehicle. Now, we need to make sure that the player is actually on a vehicle. Two things. We need to make sure that they're on a vehicle, and we also need to make sure that this script that we're referencing, or that we're in right now, that it only controls one of the gun gooses, because I want you guys to be able to just drop down this prefab into your maps multiple times and still have this work. I don't want this script to control every gun goose, because then if somebody boosts, it's going to boost somebody else's goose, and it's going to be all wonky and it's not going to work. So what we're doing here is we're saying, is the player's vehicle a valid object? And we're going to get the prefab that we're referring to here, which I should rename, but it is prefab 2 right now. We're just referring to, when we say prefab 2, it's this whole object. I've created a prefab out of this gun goose, the script, and these little fire effects, which I haven't implemented yet. So that's what we're referring to with this prefab. So we need to kind of dissect that prefab using the get objects and prefab node. You can find that one in the objects. So there is, it's a little tricky to find, but it's here, get objects in prefab. So yeah, it just basically gets you all objects that are contained within it. And then we're saying object is in list. Is this vehicle, right, that the player marked, is this vehicle that the player is on, is that in this list of objects from the prefab? If so, the output from here is saying, yes, this is the gun goose that this script is controlling, and this right here is saying, yes, the player is on a vehicle. So we're combining these two together, and then using this Boolean logic node, and we're saying and. So when we say and, it means that both of these have to be true in order for this here to execute. So, well, for this to be true, sorry, to execute, it's based on this branch is what does that. So the branch is saying, if the player is on a vehicle and that vehicle is the one that this script refers to, continue. Next thing we're going to check is, can they boost? Right? Remember I said that you can't just spam the button? Well, that's because what I do is I say, can you boost? And then if you can, set boost to false. And then at the very, very tail end of this, we finally set boosts back to true. Okay? And when we get to here, you'll see how that flows. But the next thing that we're going to do is, and like I said, with the stepping behavior, I haven't implemented anything else on the other side of this, right? So if you set use stepping behavior to false, the script will not work. You have to make sure that that's true for right now until I implement just kind of, I don't know if I'll really implement it. I might just totally throw away this kind of part of the graph. But if we continue, what we're going to do is get our number of boost steps that we set, and then we're going to loop for every number. So if we put 5 in here, we're going to get 5 iterations. And so right now I believe I have this set to 4 iterations, maybe 5. So yeah, we have 5 boost steps, and what we're going to do for every single one of those boost steps, this execute iteration, okay, if we go over here, we're going to set the object's velocity, and the object that we're going to be setting this on is going to be our goose. We're going to be setting the velocity to a new velocity. And what we're going to do in order to make it boost, we're just going to scale the existing velocity of the goose. So we're going to get the object velocity of the goose, and then we're going to use this scale vector node to scale that vector. Okay? And now we give it a scalar, and this essentially multiplies all components of that vector. So if you had x, y, and z, each set to 1, and you multiply it by 2 here, well, then you'll get a vector with x, y, and z components of 2, 2, and 2. So how did I do this little, equation here that I've been talking about, this curve, right? Well, what I did is I took the number of iterations, or the current iteration that we're on. So this will be 1, 2, 3, 4, 5 that will be coming out of here, this current iteration. And so we're going to take the square root of that. And just to give you some context, what I'm going to do is I'm going to show you over here. I have a graphing calculator. Okay? Now don't be intimidated. I promise you can do this. So remember, we get this shape kind of whenever we're working with square roots. We get these kind of shapes and stuff. So you can change this however you want. Now, let me show you kind of how these match up between the function and what we're doing. So x here is the current iteration that we're on. So this would be, 1, or it would be 2. So that's this value right here is the current iteration. This is our boost step curve scalar. So I have this scalar value in here. Right here is this is our next value. Okay? And so that's why we're multiplying. So we're going to take the square root of our current iteration. Then we're going to multiply that square root by our scalar that we set. The next thing that we're going to do is we're going to divide. So let me open that back up real quick. We're going to divide that by the divisor. Remember, this is the dividend. This is the divisor. And then the result of this is our quotient. Now what we're going to do is we're going to multiply that quotient by a coefficient. So this coefficient right here is just this value. And so right now I have it set to 1, but you can have fun and you can play with that. So if I go ahead and I start modifying this curve, let me show you kind of what it's doing, right? So I'm saying that this is our step number, right? Well, we're trying to get this y value, okay? So if we're at, let's say, the first iteration, let's go over to, I believe I can click on here, and then, so at x1, which is our first iteration, we're gonna have 0.8, okay? And next, what we're gonna have is at the 2 value, we're gonna have 1.131, and so on and so forth. And so that's what I'm doing here. I'm doing it based on this curve. I'm multiplying that value based on this curve. So you can totally have fun with this. And like I said, you can change this around. So like if I change this to x, we can get a curve that looks like this. And if we do like 3x, it'd be steeper, or 4x, or 5. And so you can kind of make up your own rules. This is not an equation. This is not a physics equation. This is not something that already existed. This is me making a curve, using an equation, and then multiplying a value based on that curve. So we get that result, that final result after doing this, and then we scale the velocity, but we do it in steps like this. And the reason that we're doing it in steps with this loop is so that it kind of has that acceleration feel, you know? It goes boom, and then eventually it might hit a point to where it really steps up, and that's where a curve like this would be really useful. Go ahead and try a curve out like that, and then see what it's like. And then also make sure that you play around with things like this here coefficient on the end. So if we do 1, 2, 3, 4, you know, you can have all sorts of fun with this. But yeah, enough with this little function here. At the very end of setting that velocity, we wait for a given number of seconds, which is our boost step duration. And then after we're done, finally, with all of those iterations in the loop, so we get to the fifth one and we boost, and then we're done. On completion, right here, what we're going to do is we're going to wait for a boost cool-off. And our boost cool-off is different than our boost duration. Our boost cool-off is the time in between when you can use the boost, right? When should that boost be available to you again? So that boost is available after the number of boost cool-off seconds. And then we set can boost to true again. So then, at the very beginning of our graph, then this will evaluate to true, and it'll be able to go through. So that way the player can boost again. So that's how I've got this set up here. Have fun and play around with these numbers here. And, you know, be creative. Like using kind of what I showed you with just pull a graphing calculator out. This website that I have right here is desmos.com/calculator. And you can just search Google for Desmos graphing calculator. It's a great utility, and you can graph multiple functions at the same time too. So yeah, it's just tons of fun. So it can be a real help when you're trying to do stuff like this and you're trying to make kind of creative, novel functions to bake into your code. So anyways, I hope that you enjoyed it, and you will get a little lag sometimes like that, especially right when you start up, and but then after that it seems to kind of chill out a little bit. So if I boost again, boom. And you can definitely adjust this curve to have whatever kind of behavior you would like. So I hope you like that one, and give me any questions. If you'd like to see this with an air vehicle, let me know. But I encourage you to go ahead and try it out yourself and see if you can get it to work. So thank you so much for watching. I will see you in the next one.